Okay, in this video, we're going to cover the last unit here. Sorry, it's a little bit crooked right now. It's the last subunit of chapter 1, mathematical modeling and variation. Okay, so we're actually going to focus more on the variation part simply because this part we need a lot of graphing calculator technology, which we don't necessarily have in some cases. So just to kind of make it fair, we're going to just focus on the variation part. Okay, so we have direct variation is our first type of variation, and this is when in a given model, y varies directly as x or is directly proportional to x. So the model for this is y equals kx, where k is non-zero, so k cannot equal to 0. By the way, k is called our constant of variation or constant of proportionality, okay? We're going to start with a word problem here. I'm not sure why this is so crooked today. Let's see. Forgive I kind of wrote on this before and I did not realize I was not recording, so forgive that. So we have the simple interest on an investment is directly proportional to the amount of the investment. Okay, so in other words, the money is directly proportional to the amount we put into it to begin with. Okay, so for instance, an investment of 2,500, so think of this as like your X, that's how much we put in, okay, earns this much interest, $187.50 after a year. Find a mathematical model that gives the interest I after 1 year in terms of the amount invested. So you're going to see here that we have y equals kx, because I just went ahead and wrote it here so we can see what we're referencing. Our y is going to be how much money we earned after that year. So it's going to be this 187.50. And our x is going to be the amount of money we invested. What we're looking for is, in fact, the k, because we want the mathematical model. So we want to know y equals what constant of proportionality to give me whatever amount of money I invested. If that makes any sense. Okay. So I'm going to go ahead and start this one a little bit fresh just because I don't want to, I had already kind of done some work here. So you're not confused. We have, instead of y, okay, let me rewrite it here, y equals kx. Instead of y, we're going to have I, okay, equals k times the amount invested, so p. So in this problem, it looks like the amount invested was 187, I'm sorry, the amount earned, not invested. The amount earned was 187.50. Okay, and the amount invested was $2,500. So we're going to go ahead and solve for K. To do that, we divide both sides by 2,500. And it looks like that's going to give us, let's see, I had already calculated it, but let me do it really quickly again. So 187.5 divided by 2,500 gives us k equals 0.075. Okay, and any normal for function should allow you to do that. So for our equation, okay, which is what we're looking for, it would be I equals 0.075 p. So we're going back to what we originally looked at over here. Okay, and that is pretty much it for this first example. Let's move on. A couple more things to copy over here. Now we have direct variation as an nth power. Let me get this. I don't know why, like I said, this is just not working out for me today. Direct variation as an nth power. Okay, so I kind of started off with an example just to show you what I mean by nth power. A equals pi r squared is a pretty popular formula. It is the area of a circle. Okay, we can see here that, and there's nothing to solve here. I just kind of gave you the information that the area, so A, is directly proportional to my radius, but the radius is squared. So it's directly proportional to the square of the radius r. In this case, our k would be the pi. So pi is the constant of proportionality or constant of variation. Okay, either one works. Let's look at a definition now officially. We have direct variation as an nth power is y is directly proportional to the nth power of x, or y varies directly as the nth power of x, Here is the model. It is very similar to the first one, except that now it has a power. Please note that the first example we did is actually this same one where n is equal to 1. This power of 1 is going to give us the same variable here. Let's go ahead and look at an example. We have example number 3, neglecting air resistance. The distance s of an object falls varies directly as the square of the duration t of the fall. Okay, so this guy varies directly with t. S varies directly with this as the square of this. Okay, an object falls a distance of 144 feet in 3 seconds. How far does it fall in 6 seconds? So what we're going to do first, we're going to go ahead and write our y equals k x to the n power first, just to kind of match up to see what goes with what, okay? Okay, so it looks like our distance s is the first thing that's mentioned here. It's also the one that says that it varies directly with the other. So it looks like this is going to be my y. So distance s would kind of be our y, okay? And this varies directly as the square, so there's our exponent right there of the duration t. So s is equal to k times t squared. And that's the formula that we're going to be looking at, okay? The question is, how far does it fall in 6 seconds? So in order to find how much it falls in this time, we have to find the equation first. So we're going to go ahead and plug in what we know into this guy here, and then figure out what k is, and then we can find how long it takes for it to fall in 6 seconds, or how far it falls in 6 seconds. So let's see, we know that the distance is 144 feet, and we know it happens in 3 seconds. So this equation right here would be, if I plug stuff in, would be 144 is equal to k times 3 squared. And we're just going to solve. So let me move this down a little bit. So 144 equals k. 3 squared is 9. Okay, we're solving for k. Divide both sides by 9. And that will give us, let me see, 16. So our constant of variation is 16. So this means, and I'm working kind of backwards here, but that's okay, that S is equal to 16 t squared. So this is our equation. Okay, now we have to find out what happens when, let's see, how far does it fall in 6 seconds? So when t, which is the time, is equal to 6 seconds, okay, what is S? So S is equal to 16 times 6 squared. All I'm doing is I'm plugging in this number into the t, to our time. So that's going to be 16 times 6 squared is 36. Okay, we multiply this out, and that gives us 576. And we're talking about distance, so feet. And that's it. Pretty easy, hopefully. Okay. Next example, I believe we're going to be dealing with inverse variation now. Yes, we are. So here we go. We have our definitions up here for inverse variation. By the way, the definitions are more equivalent statements than what you might see for these types of problems, okay? So for inverse variation, you will see something about something varies inversely as the other, okay? And you might also see y is inversely proportional to x. So something is inversely proportional to the other. The model for this one is a little bit different. This one is going to be a division problem because you're thinking the inverse. So since the one before was multiplication, the inverse of multiplication is division, okay? So there we go. Again, our k is still non-zero. Please take note that if it's inverse variation with a power, it works the same way, except now we have a power in the denominator as well. Okay, so let's go ahead and see an example of this one, see how it works. We have, oh, excuse my, I'm just full of mistakes today. I forgot a few words here, so make sure you write it in a nicer sentence than me. Example number 4. Companies demand for its product, okay, varies inversely as the price of the product. So we have that The demand would be kind of like our Y, okay? And the price of the product would be our X. Okay, so demand and the price. Usually you can get it from the first sentence. Okay, when the price is $6.25, the demand is 400 units. Approximate the demand when the price is $5.75. So here we have another example. We have that the price is $6.25. Remember, price is going to be our X, and the demand is 400 units. So that's our Y. So just let's keep that in mind. So we're going to write out, just like we did before, our inverse variation formula, so to speak. And we're going to fill in what we have because we want to find the demand when the price is this much. But to do that, we need to find our constant of variation first, the K value. So we're just going to plug stuff in. And since they're not asking me for an equation, I'm not going to bother with changing the letters. I'm going to leave them like that for this one. That's okay. So for our Y, we have 400, okay, is equal to K over X is $6.25. Move this down a little bit, okay. And for this problem here, we're solving for K, so we're going to have to go ahead and multiply both sides by that 625 to get rid of the denominator here. So essentially what we're looking at is 625 times 400 is equal to K. So let's go ahead and calculate that really quickly. And I'm getting 2500 is equal to K. Okay, so this means that our equation, or you could even say our model, okay, our mathematical model for this one here is going to be Y equals 2500, because that's our K value, divided by X. Okay, and we're going to use this to find the demand when the price is 575. So when price is, so when X equals 575, okay, what is our Y? Y equals 2500, just plug it in, okay. I'm gonna go ahead and calculate that super quick because it's Friday and I do not want to do stuff in my head right now. So I am getting 434 and 78 cents approximately. So when the price is this much, okay, we are getting, oh, actually it's not money. What am I doing? This is not money, my bad. This is what happens when you don't read the problem. When the price is this much, the demand is this many units, okay? So approximate answer. And that is it for that one. Okay, so in example 5, we have a combined variation problem that includes direct and inverse variation. Okay, so we have the volume of an enclosed gas varies inversely. So there we have some inverse variation. Okay, so the volume, that's actually what's varying. So this is our Y. Varies inversely as the pressure, okay, and directly as the temperature. So directly as the temperature. So it looks like these two guys are going to be on the right side of the equation. The directly one is going to be multiplied, okay, because remember direct is Y equals KX, and this one is Y equals K over X. So we kind of have the temperature on the top and the pressure on the bottom. So let's just keep that in mind, okay? The pressure of a gas is 0.75 kilograms per square centimeter when the temperature is 294 Kelvin and the volume is 800 cubic centimeters. Write an equation relating pressure, temperature, and volume. So all we're going to do for this one is write the equation. And we're going to do that by figuring out what our K value is, okay? So we're going to use what we have. We know that the pressure, so the pressure is 0.75 kilograms. We know that the temperature is 294 Kelvin and the volume is 800 cubic centimeters. So we know that the volume, based on what I did up here, is going to be our y. So let's go ahead and write our equation before we even do that. We know that y is going to vary inversely. So we're going to have k over x, right, times something else here. I'm just going to call this m because it has both of them. So I can't put another x because it would just cancel out. If that makes any sense. So we're going to go ahead and plug stuff in. Our y would be our volume. We don't know what k is, okay? But we do know that the top part is directly with our temperature. So temperature is going to be right next to it, and it varies inversely with the pressure. So let's put P on the bottom. So this is the formula that we're going to use, okay? So I'm just going to plug all these numbers into here and figure out what K is. So 800 is equal to K times our temperature of 294. Okay, and I'm not worrying about units quite yet. We'll worry about it at the end. Okay, divided by the pressure. So the pressure is 0.75 kilograms. Okay, so all I'm going to do is solve. So I would probably do kind of like a cross multiplication for something like this. So it'd be 0.75 times 800 equals K times 294. Okay, so let's go ahead and do that really quickly. And if you can do this all in one step, that's great. So I'm getting 600 on this side equals K times 294. Our next step is to divide both sides by 294. And that gives me 2.04. So our constant of variation, K, is going to be 2.04. So now that we have that, we can go ahead and write our equation. Remember, this is the equation. So volume is equal to, okay, 2.04 times the temperature divided by the pressure. And this would relate our pressure, our temperature, and our volume. Problem has to do with joint variation. And I went ahead and just included it here in the parentheses so you wouldn't have to write too much. It's pretty much the same as direct, but now we have another guy. So it's kx and the y, okay? Let's go right into the problem. We have the simple interest for an investment is directly proportional to the time and principal. So in other words, the interest, so this guy, the interest for the investment, this is like our y. Okay, remember usually the first sentence tells you where to start, okay? And this is directly proportional to the time and principal after 1 quarter. Be careful here because if you don't remember how to do simple interest has to do with years. So 1 quarter is actually going to be 1/4. So think of it like 3 out of 12 months is the same as 1/4. Okay, so be careful with that. Okay, so we're going to start by writing out the equation. So y, or actually not y, I'm sorry, z, because we don't want to confuse that y. Okay, so z equals kxy. Okay, so I should probably change this guy to a z because this is our z here. The first thing we talk about. This varies jointly with these guys. And we are going to change these to stuff that we know. So our z, okay, would actually be the same as our interest, okay? And this is jointly proportional to the time and the principal. So time and principal. So this is the one that we're going to be kind of looking at, okay? So let's go ahead and use this to figure out what the interest is after 3/4. I'm going to put a little note here that 1/4, okay, is equal to 1/4. So make sure you take note of that because that's going to come into play over here. So let's see. I'm going to rewrite it over here. I equals K and then T times P, time and principal. Okay. And it looks like our principal is 5,000. Okay. And it's saying that the interest on a principal of 5,000 is 43.75. So this is the amount of money they got from that money. So that's going to go first. So 43.75, okay, is equal to K times our time. Our time is going to be this 1/4, which is the same as 1/4. And then our principal is $5,000. So we're going to go ahead and multiply this and then divide it from this side. So I can do this all in one step, just so you can kind of see. Well, yeah, I guess I can do that. That's fine. So essentially what you're doing is you're going to divide the K by whatever's over here, right? So we got to divide this side by that as well. And I'm just doing this one step to save some time. So let me go ahead and calculate that really quickly. Okay, so I'm getting 0.035 for my K. Okay, so this is important because this goes back in this formula. Let's scoot this down just a little bit. So our equation is actually going to be I equals 0.035 and then TP. So this is what I'm going to use to find the answer to that last part. It says find the interest after 3/4. So I guess we're going to be using the same amount of money. So for my question, okay, we're going to have I equals 0.035 times our time. If it's 3/4, okay, think of it like 3/4. Okay, so 3/4 is our time, and our investment amount is, or principal amount, I should say, is $5,000. So there it is. Just plug all this into a calculator. So let me do that real quick. And I am getting $131.25. And that is it. Okay, so if you have any questions, guys, these ones are not too difficult. It's just a matter of knowing what's what. Okay, as you can see, I kind of made a lot of little errors here, mostly with the letters. So if you do have any questions, let me know. Remember, you will not have any homework with this one, but it will be on your final exam, or not final exam, your first exam. Okay, thanks.